little bit harder because it's not written in the form as factors, right? So factors are things that are being multiplied with each other. However, this is not written in a way that it's factored. So because it's not written that way, guess what we're gonna have to do? Factor. So the first step here is we need to factor. So we need to factor the numerator and the denominator. Because in order to cancel things out and simplify, it has to be in factored form. So to factor, good thing we know how to do this from the previous chapter. So to factor this, I look at the top. There's two terms, but before I try to do anything fancy, the first thing I'm gonna do is find a GCF, right? So 32 and 2, what is a GCF? And I think you guys are unmuted, so feel free to speak up if you guys would like.
2.
I'm sorry?
2.
2, right. The GCF is 2. So I'm gonna pull out the GCF, and inside you can do two spots. 2 times 1 will give me 32. 16, right? And then 2 times what will give me negative 2w squared, a negative w squared. And I always double check. So what I do is I always just multiply through here to make sure that I get the original right there. The denominator, I have w squared minus 2w minus 8. So first of all, I ask myself, is there a GCF? And the answer is no. So next I'm going to say, well, there's 3 terms, so I'm going to have to factor it. So I'm going to have to factor it by using Xbox method because there's 3 terms. So if I factor that, I have w times w give me w squared. 2 numbers that will give me 8 is 4 and 2. One of them is going to be negative. Not sure which one yet. So I'm going to cross multiply to do the x. Oops. And when I do the x, I get 2w. W times 2 is 2w. W times 4 is 4w. Can I add or subtract this to give me a negative 2w? Yes, I can. If I put a negative 4w there, I end up getting negative 2w. So that means I need a negative here, and the negative 4 times 2 does give me negative 8. So these are my winner chicken dinner numbers. So when I factor this, it becomes w minus 4 times w plus 2. So when I look at this, I'm like, okay, I'm done factoring. But guess what? You're actually not done factoring because remember the factor man, when we looked at that sheet, you want to factor everything to death. If I look at 16 minus w squared, these are 2 terms. Can I factor this anymore?
Yes.
Yes, you can. And you can factor this, and since there's 2 terms, it's either going to be a dots, a difference of 2 squares, a doptica, difference of 2 cubes, or a soctica, a sum of 2 cubes. What do you guys think this is going to be?
Difference of 2 squares.
Right. 16, it's going to be a dots, right? So here, 16 minus w squared is going to become, anyone know what that's going to be? Difference of 2
4 minus 2.
4 minus w.
4 minus w times
2.
not 2.
No, not 2. 2.
Again, 4 minus w times
4 plus w.
right. Good job. 4 minus w times 4 plus w. So remember the difference to 2 squares is a squared minus b squared is equal to a minus b times a plus b, right? So your a is 4, because 4 squared gives you 16. Your b is w, because w squared will give you w squared, right? So 4 minus, so it'll be 4 minus w times 4 plus w using dots. So again, if any of you guys are fuzzy-wuzzy on how to do the dots, please make sure to go back to the previous chapter and watch my video on difference of 2 squares. But right now, I have this. So let's just make it nice and neat. A lot of math is about organizing your work. So I have 2 times 4 minus w times 4 plus w all over w minus 4 times w plus 2. So these are all factors now. So I have factor, 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 factor. Do any of these factors look the same? Is there a two? No?
The 4 minus w and the w minus 4 are the closest thing.
Great. So Alexis said the 4 minus w and w minus 4 looks the same. So let's take a look at that. So I'm gonna pull that out here. So let me erase this real quick. So I'm gonna pull this out, the one that Alexa said. So 4 minus W over W minus 4, are these the same?
No,
Why not, Tim?
because it's a negative W and on the bottom is not negative W.
Okay, great. So the 4 here is positive, the 4 here is negative, and like Anthony said, the W here is negative, but the W here is positive. So they're not exactly the same, but they're so close. And actually, if you pulled out a negative, so what I'm gonna do is I'm gonna show you something. They're exactly the opposite. This is a 4, negative 4. Negative W, positive W. So what you can do, if you pulled out a negative, if you distributed out a negative or factored out a negative from the top, if you took out a negative on the top, this 4 will become a negative 4, and this negative W will become a positive W. And here, I'm going to just switch the order here so you can see this is negative 4 plus W. So what you're going to see here is that negative 4 plus W, negative 4 plus W, they're exactly the same here. I put a 1 and 1. This actually equals to negative 1. So I know that's a little bit confusing. So when the top and the bottom are exactly the opposites of each other, meaning here's a positive 4, here's a negative 4, here's a negative W and a positive W, the answer becomes a negative 1, right? Because let me just show you something. If I had A divided by A, right? If the top and the bottom are exactly the same, you just get a 1, right? But if I had an A over negative A, if they were exactly the same, but they're just different by just a negative, then the answer would be a negative 1, right? That's the same story with this. 4 minus W and W minus 4 are exactly the same, except they're exact negatives of each other. Just by pulling out the negative here, and put out a negative to show that the top and the bottom are exactly the same except the negative, and that becomes a negative 1. So it's a little bit tricky. That's why I did this problem. So 4 minus W and W minus 4 now becomes a negative 1, and a negative 1 is just a negative, right? So you can put the negative 1 on top or negative 1 on bottom. It doesn't matter. So when I now simplify this, I get 2 times the negative 1, which gives me negative 2, times 4 plus W. The bottom, well, the W minus 4 and the 4 minus W canceled out, right? So that just became a 1. And then here I have a W plus 2. So again, it's not easy. This is pretty challenging. So this is our final answer. And notice there's a 2 here and a negative 2 here. A lot of students think that they can cancel out the 2, but you cannot cancel out these 2 because W plus 2 is a factor. The 2 is attached to the W, so you can't just cancel it out just because you see it on top as well. W plus 2 is a factor. It's stuck together. You can't, basically, like you can't chop off an arm from a head, from a body, right? So W plus 2 is a whole body. You can't chop it. So you can't take it out in pieces. They're together, right? I know it's a little bit challenging, so we're going to do a few more examples. Do you guys have any questions on this? I know, so take it all in. Let me give you guys a chance to, do you guys want me to do another example, or do you guys want to do a you try, where you guys do it on your own?
Can you do another example, please?
Sure. Let's look at number 8. So number 8 is going to be something similar to what we just did here with the W, 4 minus W and W minus 4. It's really to hone in the point that if they're opposites, you can simplify it to make it a negative 1. Okay, so looking at number 8 here, I have 4 plus 3v over 3v plus 4. That's the first part. And the second part is this. And where's my blue marker? I lost it. All right, so the first part. First of all, can I factor this? 4 plus 3v. Can I factor 4 plus 3v?
No.
No, right? Can I factor 3v plus 4?
No.
No. So since it can't be factored anymore, this is a factor, this is a factor. So that's all, this whole thing's a factor because it just is what it is. You can't do anything more with it, and this is a factor. And then I ask myself, well, are these the same? If they're the same, then I can simplify and cancel it out. Are these two the same?
Yes.
Yes, right? Positive 4, 3v, 3v. It's like saying a cat plus a dog is the same thing as a dog plus a cat, right? They just switch the order, but they're the same. So again, if they're the same, you get divided by itself, so it just becomes a 1,
More.
right? This one's a little bit trickier. First of all, can I factor it?
No.
Nope. It's already factored as is, right? You can't make, there's no GCF. So therefore, this is a factor and this is a factor. You can't break it up anymore. Are they the same?
Yes, kind of.
Kind of, right? So Felicita, can you explain why do you say it's kind of?
Because like the last problem where you took out the negative.
Mm-hmm. So let's say I'm going to take out a negative here. If I take out a negative, what does the inside become?
-7 plus 2v.
Great. Now, is the top and the bottom the same?
Yes.
Yeah. Great, good job. So the top and the bottom, this is a positive 2v, positive 2v, -7, -7. These are the same, so we can cancel them and it becomes a 1. So I have a 1 divided by -1, which would just give me
-1.
-1. Any questions on that?